Okay, hello, good morning, good afternoon, and good evening to everyone who's tuning in. Hope you're doing well and staying safe. On behalf of BOGSP Student Chapter, I'd like to welcome you all in our first session of Digitalization and Oil Fields course. I'm Mona Jaza, Membership Chairperson of BOGSP, and I'll be moderator for today. Our today's session is entitled Digital Drilling, and we're very honored to welcome Engineer Hendrik Suryadi, a very special guest from Schlumberger, to be our instructor for today. This is a part of our lecturer's experience. Engineer Hendrik is a drilling domain champion at Schlumberger, experienced digital product analyst, product champion with a demonstrated history of working in the oil and gas industry, skilled in digital product development, logging, directional drilling, and well engineering. He has a bachelor's degree in mechanical engineering from ITP. Attention, please don't forget to drop your questions in the Q&A section below, and please keep the chat box professional and ethical. So without further ado, let's welcome Engineer Hendrik. Mic is yours, you can go ahead.
All right, so thank you so much. So I'd like to thank for the SP student chapter for this opportunity. This is my pleasure to be able to talk with you all and also have opportunity to share some of the knowledge and also to give you an update on what's going on with the industry and especially development of technology. In this case, is the digital technology, right? I assume, I don't know what is the background of all of you, right? But I assume most of you is currently doing a study, right? And so my when I was being requested to give this lecture, right, I was asking what is the expectation, right? Especially, so my assumption is that you want to know what's going on with the digital drilling. First is what is digital drilling, and right, I mean, and what is the latest development, or how is the progress in this area. So I have a lot of slides. I have almost like 60 slides. So how much time do I have?
2 hours maximum.
2 hours maximum. So I'll see, right, how much we can cover, right? But I don't want this lecture become boring lecture as well. So if any time you have a question, feel free, just shout. Just unmute yourself and then just shout. Just pretend I'm in the same room as you guys, right? Rather than you wait until the end and ask question. It's better if you have anything related that you want to know more, the particular topic that I'm showing you, is better speak out, right? Then we have more live discussion. And yeah, how much you know, I hope you take this opportunity. If anything you want to know, then ask the question and we can discuss further. Having said that, I mean, digital drilling have a broad scope, right? There's so many things to cover within these 2 hours, or I mean for at least 1.5 hours, and then we can discuss more for the rest of half an hour. So I will not be able to tell you in details, right? But what I'm expecting is hopefully I can just give you enough information or an overview of what is digital drilling and how we're doing digital transformation, especially in well construction or in drilling planning and operation. What things, some of the use cases or example of area that being developed or being implemented or being used in industry. And hopefully this giving you an insight, giving you information, giving you an idea, especially if you are a student now, to see things that you can explore further, to find out more details, or even it's good if you nurture some of innovation spirit that you can do, because a lot of this digital uh, solution development, it come from people like you. It's coming from startup company, it's coming from a student, and your generation is more adverse on digital technology than probably my generation, right? uh, I just my so okay. So talk a little bit of myself, so you understand where to let you understand where I'm coming from. I'm 23 years uh, with the industry. All these 20 years always with Slumberjay, or now the company is actually called SLB, right? We changed the name to SLB. Uh, I'm starting in the field, right? As a driller, as LWD engineer, and I moved to directional drillers as a driller, and as I become drilling engineer, planning the well, and I become drilling engineering manager. So half of my career is more into operation, especially on drilling operation, right? From planning or going to the field as a directional driller and etc. And then I got the unique opportunity when we starting this digital transformation journey. The company feel that they need someone who understand about drilling, and then being put in the technology center and start talking with software engineer, with data scientists and everything. So half of my career, about 11 years, I'm working with digital product or digital technology development. And now after 11 years that, and now I'm going back again to the operation here in Abu Dhabi for the Middle East market, is trying to how we can utilize some of those digital technology in the operation. And I'm working as a consultant uh, for well engineering, and also how this digital technology being implemented in the operation, improve the efficiency in the operation or in the planning, right? So that's a bit of my background of myself. So what I'm gonna today talk is about digital drilling, how we leverage the digital technology and artificial intelligence, particularly in well construction process and planning and from planning to execution, right? All right, just give you a background. Probably you've been hearing many of the digital transformation slides, but I have to tell the story from here, right? Why we suddenly the industry start talking about digital? Because there is a promise that bring by digital technology. Oh, sorry, I haven't shared my screen. Yeah, can you see my screen now?
Yes, clear.
All right, all right. So I have to start from here. Let's talk about what is the background, what is the context, why we have to embrace this digital technology, right? Because there is a promise of digital. The digital technology being used in many other industry, right? Travel industry, banking, governments, you name it. And oil and gas is actually behind those things. We've been embracing many technology to help us planning the well, drilling the well, producing the well. We've been collecting many data, but not really we embrace a digital transformation. So we be late on that. But since now we need to find some new technology that can help us to improve our efficiency, delivering more energy to the world. Then we need to embrace this digital, and digital technology. This is some of the study, market study, right? In simple, I don't want to spend too much detail on this. What it's saying is there is a lot of improvements can be done if we start using digital technology to help us to explore better, to do well construction better in planning, or to produce in production, right? So there's some improvement, 30% real faster, more oil production, etc., etc. Right? And then if you're looking at the futures, right? Yes, there is a promise of digital, but we need to see also how is the future. We still have a long way, even people talking about, oil and gas is going to die or should, but no, I mean, still a long way to go, because the world need energy, and they were as smart as they say that they want sustainable energy, but oil and gas still playing a role in that, because like it or not, the 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 price of energy with oil and gas is still more competitive than other way of technology. And but we just need to make sure now the how we produce those oil and gas energy is in more sustainable way. Means we need to start taking care of the emission. We need to do it more efficient. If we can reduce the amount of material that being used to do that, then we reduce the emission as well. And to do that, we need to embrace innovation, especially related to digital on any other the technology development. So because of this, all this is driver, then we start look at what we can do with digital technology. If we go back, what is the challenge, especially on drilling, right? The challenge is still the same. Or I mean, the drivers is still the same. We want to drill faster. We always want to increase performance. Now we start thinking about reduce the footprint as well, especially for the environmental impact. We don't want any non-productive time, right? We want to drill safer well. All these things remain the same. We just additional now is want to reduce footprint, we want to reduce emission, etc. But over these years, the challenge or the pain points of, for example, well construction team doing that or to achieve this target is still the same. We've been drilling well, hundreds of wells, thousands of wells, but sometimes we cannot really deliver a consistent performance, right? Sometimes we have a good well, very successful. The next well, we still have failures, and suddenly we have a trend wreck and everything. Why we cannot drill a consistent performance? Collaboration. Well, construction team is always involving a lot of people, right? For different role. There is a drilling engineers, there is a service company, there is a geologist, there is petrophysicists and everything. And we spend a lot of time on emails, meetings. Why we cannot working together better, right? And of course, there's a lot of disconnected workflow and everything. And this causing, we have still making mistake. We still making human errors. We don't spend enough time to learn from the previous experience on the offset well, just because we just don't have enough time. People on the team is always busy, while we trying our best to create the best drilling program. Sometimes when we start executing the well, the people on the rig, we just don't have a clue. I mean, or sometimes do not have enough information, despite we delivering like hundreds, 200s, 300 pages of drilling program, right? And then at the end, it's just too much information for them, and they will just doing it as they like to do, right? So looking at these drivers, looking at these challenges, we step back and say, okay, now if we want to bring a digital technology, how we want to change the way, or what is the vision of bringing these digital tools or an enablement or technology in our well construction process? What is the vision? What if we want? So digital transformation is a journey, right? It's not like you take the technology and then you implement, you develop something, but digital transformation is more changing also the culture, the way we work, right? And so then the vision is still go back again to plain. So in drilling or construction, we used to heard the concept of plan, execute, and evaluate, right? And that concept is still true, right? It's still valid. It's all about when you plan, how you execute, and then you evaluate after you execute, and then you start the cycle again, right? But even we understand that concept, we not necessarily can implement it seamlessly. We spend a lot of time on planning. It can be months, 6 months, years before we execute. We execute, we collecting a lot of data. Sometimes we just don't have enough time to evaluate because we already busy on planning the next well, right? And the reason that we don't have enough time to evaluate is just because when we collecting data, it's not easy. Suddenly we kind of draw the lesson learned, draw the insight on what things we can improve to plan the next well better. So we step back and then try to think what we want to improve in terms of how we plan the well, and then how we operate, how we record the data, and then later on how that allow us easy to learn so we can feeding back to the next plan, right? So from this point, what you start seeing is some of the terminologies, basically the name of some of the technology that SLB developed, right? So you will see more about drill plan, which is our planning platform, and drill ops is our execution platform. Is already being used on the rig or being used in town from our monitoring center, right? So there is a drill ops town, a drill ops rig, or drill ops town, right? So first in drill plan, in drill plan or in terms of planning, what we expect in the planning work, we need to have a better way to collab within the well construction team is to collaborate. How we can work together, right? It is different role. There is drilling engineers. There is a uh, uh, operation engineer. So there is a fluid SME, cementing SME, geology. How we spend less time on back and forward sending emails, sharing the data, sitting down together in the meeting, but how we can just work together in the drilling program, how we manage that, and is there anything that we can automate to help us reduce manual input or manual processing, right? And also in the planning, for sure, we need to, as much as possible, to learn from what happened in the previous well. And the other thing is how a planning platform can be extensible. I'll explain what is extensibility means. It's open to any other solution. For example, if you want to calculate a specific analysis, for example, casing wear or advanced temperature modeling, how the system can communicate with some this advanced engine and then get back the result, right? So if we're doing planning here, the next thing is then we send drilling program to the execution, right? For them to execute. But now can we transfer it digitally? Because if our dream, if the execution phase, we want to deliver a top performance, then we need to start embrace some automation there. Basically machine doing the drilling for us, right? How the digital technology or the application can control the rig equipment to run the drilling process automatically. But in that case, of course, the machine need to read something digitally, right? How during the operation, a system provide a real-time risk detection. If something's going to happen, need to warn first before it actually become an incident, right? And how the system can make decision what parameters to use to for the optimal performance. So we're gonna see all of this aspect. Then during the execution, we start recording a lot of data, right? From all the sensor, the surface, in the downhole, everything, send it to the server on the rig or to the box there. How this one become a structured data that is good enough that you can build an AI or machine learning application or workflows that using those amount millions of data being collected to help you better either for the next planning or what happened to make decision at while drilling is happening, right? And then of course then you start want to learn from all those data how you can easily seeing the tons of data and come up with the insight. We call it insight. It's something information that's saying, oh, okay, I know that what things to improve for the next well, right? Unless you spend hours looking at what's going on in the execution, or sometimes it's not enough just you looking at one well. Sometimes you need to look at multiple wells to try to get understand what is the best recipe or best combination of your plan, right? That you can feeding for your next planning, right? So this is the vision how we embrace some of the digital technology or some technique in each of this aspect and making closing the loop, right? And become this infinity loop, right? To make sure you always make the next well better and better and better. That's what the industry dream, right? Finally you reach your technical limit with the best plan that you can make. You execute the best way you can do, right? Learn from the data that's being recorded, and let's keep doing this infinity loop, right? So in term of solution, especially what we did develop here in SLB, there is some of this digital drilling solution. I'm just gonna throw you some of the names, but my goal is not trying to selling you the name, but to give you idea what kind of specific cases we've been implementing in some of these platforms. So there's 3 platforms, right? One is Drill Plan, is a planning platform. A lot of have all the well-designed workflow application that required by the well construction team to plan the well, right? The goal is trying to coherent and collaborative planning. So the platform name is called Drill Plan. There is for execution is called DrillOps. DrillOps have 4 different you can call it application or different solution. One is orchestrate. So when you're giving a plan to the execution, the first people who need to understand is the company man, right? Or the well engineer. I don't know what you call it, operation engineer. They receive the drilling program and say, okay, now you need to execute the next well. This is the leader on the rig, right? Represented the operator. Okay, this is the breakdown on how we going to drill the next well, right? But they need to have a tool to make sure they can manage this operation as being planned before, right? So if drill plan, sorry, in the planning state, they describe the activity plan, right? Starting from moving the rig, spud the well, drilling the top hole, the conductor or whatever it is, doing section, running casing. Sometimes you need to run log. Everything is being described in the planning. That's what the rig team needed to do, but they need to be able to manage this, right? And sometimes when something happen, how they can make a decision on mitigating that incident and going back again to the plan and etc., right? And record any events that happen so we can learn for next plan. So that is the territory of orchestrate. While executing the drilling operation, is there anything can be done automatically? It's like a driller press a button, right? Please drill this section, and then let the system control the machinery and drill it automatically. Of course, as I mentioned, we record a lot of data. How the data being recorded is become very important, especially we want talking about AI, machine learning is always data driven. If you don't have data, if you don't record it properly, if you don't structure how you record the data, forget about what your solution is gonna build on top of it, right? And then how using this data to give you this automatic interpretation, right? You don't want human keep looking at the log, looking at the sensor data, and first is trying to figure out is something going to happen or how I can improve the performance while drilling, right? And etc. This is called advice. So on top of this is what's happening on the rig. or while drilling operation happened. But after the drilling operation, after the well execution finish, what things we can learn, right? That's called drilling insight, because the next question is, when you're planning the next well, anything I can improve, right? Or the main challenge of drilling engineer from the beginning when they plan the well is that which offset well I can use as my reference. It's like deciding which one is a similar well that I can use as the reference. Then I can pick the same BHA configuration, the same operation parameters configuration, the same casing configuration, etc. Right? So sometimes if you've been drilling hundreds of wells, of course, there's no exact same well that being drilled, but we just need to get help on deciding what is similar, what is the closest well I can use as a reference. So if I can pick up the closest one, I can know what I expected based on the experience of that well. Then I know what I expected to happen in the well that I plan, right? And this is where the data science start coming in place, because based on the data being collected, then you start building more AI and machine learning solution that you can feeding back again to the plan. All right, to this point, any comment, any question, right, before I keep talking further? No question?
اللي عنده أي سؤال يقدر يسويه raise hand ويسأل سؤال.
Yeah, feel free if you have a question. Just don't be shy.
No.
No. All right. So I'll continue then, right? So now, what is this mean implementing the digital technology? First, there's many digital technologies, right? There is a cloud, there is a mobile device, there is AI, machine learning, data analytics, even user interface, right? There is a specific domain expert for that, because the way we're looking at the screen, the way how we look at the chart, there is a science behind it that help us, making decision better, or be able to quickly get information, right? How we automate things, and there's many of those things. But as a technology, it will not work by itself unless it combined with the deep domain knowledge, right? So I don't know. Again, I don't know what is all your background, who in this call, but this I always got this question from students saying, "Oh, should I start become a data scientist and convert everybody become data scientists?" The answer is yes or no, right? The answer, because you still need a good domain knowledge to understand what is the problem, on what is the context in terms of domains, right? So myself, I say I'm a drilling domain champion. So my domain background is always about drilling, right? But then I can expose myself to understand about how digital technology works, right? Myself do not know how to code, but at least I can speak with the software developer, because just learning enough their language, right? Knowing what is a cloud technology, knowing what is the artificial intelligence and machine learning. I don't have to do it myself. We still require people who their expertise in that area, but as long as we can work together, right? Because even themselves, if I give a problem to software engineer, they're not necessarily going to come up with the solution that we work for us as the user or as the domain people, because their understanding probably different, and they will come up with a different thing, right? So that's why I mentioned that half of my career was when we started this digital transformation journey. The company decided, oh, I need to bring some of the domain people work together side by side with the technology development people, in this case a software engineer, data scientists, so to guide them, right? To explain to them what is the problem, what we expected as a solution, and then work side by side to test. This is what you expected. No, this is, you should do this, do that. And then when this combination is happening, then this is where we can achieve the industry goal, right? All those dream that we expect, we do faster, we get more production, and etc. Right? And this also, now we start embracing more of innovation, right? Again, by working together between those digital expert and the domain expert, not only for drilling, even for reservoir engineering, for the petrophysics, the GNG production. So there are three ways in terms of in SLB. We open for this innovation three way. First is what you call it, AI embedded, where we are in developing our technology, as one mentioned, those drill plan, drill ops, drilling inside. We start embedded some of the AI technique in those solutions. But industry, even ourselves, we make our platform open. Open means because we want to allow people like you guys, scientists in the university, in a startup company, to create your own AI solution, right? Why have to be wait until being part of a company to embed it? You can develop any AI solution, and then if your solution is good enough, it bring a value, right? We allow to be able to communicate with our solution, or even one day is being acquired or being purchased, and then start become embedded to this AI. But sometimes the company, let's say, oil company, they have their own way of technique to develop solution. They can create it themselves, right? Doesn't have to be passed on to technology developer to create it for them. They can create it themselves, become their own IP or become their patent. They can leave it, host it in their own environment, put it in somewhere in the top secret server they want to keep. But as long as the application can communicate, and that's what we expect to happen through the concept of extensibility, right? Or there are many, you call it like a software shop, or a group of data science shop that, let's sit down, I have this problem, right? I bring my domain expert. I don't have a data scientist. So this is the shop, like in Samberge, is called Innovation Factory. We have a bunch of data science working there. We sit down and then we develop it together, right? Because the world of AI or machine learning, sometimes the challenge is very unique. The way you store your data, the way you record the data, probably different than other company, right? So it's basically AI innovation is open for everybody, right? So talking about some of the how we embedded some of the AI solution into digital drilling solution, there is many use case, right? For example, in the planning. So I already show you some of this. For example, planning, how we can use that to predict an event, right? Again, it's very important while you're drilling, if the system's smart enough to tell you something's going to happen, right? How you come up with this predictive analysis? Well, you learn from your past experience, right? You learn how is the relationship with the different parameters at a particular formation, and you see that when I start seeing this torque value, or when I implement this flow rate and weight on bit, this what happened last time. So there's high probability this issue is going to happen again because you implement exactly the same method. But only machine can remember what happened, unless that's just what human learn, right? Unless you've been drilling in that well for 20 years, then you also gain those kind of insight inside your head. But we rely on people experience, and in this industry, people in and out and changing people, we cannot rely on that. But if you put it in the system, and the system is smartly enough using all those knowledge, right? And it can give you this. This is predictive analytics, means telling you if something's going to happen or what they expect its performance, etc. Right? Again, the same thing is on deciding what is the best parameters to get the best ROP. You've been drilling hundreds of wells, thousands of wells. You're using various different of weight on bid, RPM, flow rate, you name it, and you know what you got last time in your ROP. Can I learn from that? So now I currently am doing my drilling my current well, or even planning my well. I need to make decision as a drilling engineer. What weight on bid and RPM I need to use, what flow rate I need to use, right? And how you know is that combination of parameters will give me the best performance, right? Cognitive computing. Cognitive computing is how to make machine start thinking like human, right? So in short, how I can make a machine start thinking like a driller. And this is the job of driller, right? Is you need to drill stand by stand. And there is a certain sequence the driller will do. Is he gonna start the pumping first, or is gonna take the bottom first, right? Just imagine while you're drilling, if you're a driller, right? You're controlling all those you're controlling the brake, you're controlling the pump, you're controlling the top drive. There is a sequence of operation that you need to do, right? So imagine you make up a connection, you start connection. Okay, what am I gonna do? I'm gonna start pump. How are you gonna start the pump? Are you gonna go to the maximum, or are you gonna start pumping it slowly? There is a certain sequence or procedures you need to follow, and there is always consequence of that. How fast you bring up the pump, it can affect how much is the pressure spike happen downhole, right? And then after that, you need to do what? You need to rotate. How much you need to rotate, and you need to do survey. You know how long you need to wait for this, etc. All those is sequence. If we put that sequence and let the machine doing it themselves, you know, the machine need to understand the context exactly as a driller looking at all these panels, right? Before I start seeing this pressure, I will not increase the RPM, for example, right? So that's always what we're cognitive computing. If we train the machine to be able to control the rig equipment and make a decision on the fly on how perfectly start drilling a stand, then that's the root of automation. Now the driller can just press a button, start drilling, and let the machine handling all those different steps. So that is drill stand. I'll explain you more details later, right? We can embrace natural language processing, right? On how let the machine start reading the information. As a drilling engineer, what we start normally before we start planning the well is we reading all the offset well and off well report. Why are we doing that? Because we want to know what's happened in the previous well. If you have 10, 20, hundreds of offset well, how you gonna, you know, learn faster? Can I just give it to an application with the capability of natural language processing, scan please this document, it will read it for you, and then you just ask the system, give me the summary of all things what happened in the past, right? So if the system is smart enough doing that, then it will give you, because what you need at the end is just summary, right? And can now the system doing a reporting for me, right? Instead of I'm sitting in my desk, right? Every day spend hours to create the report, right? Then on top of that, after you collect your data, is how you learn from the data, how you select the offset well, and then how the system start smart enough to giving you advice, right? Like this, you know, all whatever you see in the Hollywood or futuristic movie, right? There's a smart system telling you, please do this, please do that, you know, please don't do this, etc. That's it's how you can use neural network for the advisory workflow, right? So let's start seeing in more details, right? But before that, let me bring you first to how we're doing things traditionally. I will call traditionally, right? Many still doing it even right now, right? So how we do things, especially now is in like planning the well. how we planning the well without start doing with through this digital technology, right? I don't know. My as being introduced before, my background study is not petroleum engineer, so I don't know what you guys learn in petroleum engineering. Let's say there's many petroleum engineer here, because my background is mechanical engineer, right? But I just end up in the oil industry as a driller. So I don't know when you learn in petroleum engineering. Let's say you learn about drilling. I don't know how many hours there were at. My first question is how many software did you use to plan the well? Anybody can guess? Let's say if you get a task, please prepare drilling program. And inside drilling program, there's many things, right? You need to design trajectory, you need to design wellbore geometry, you need to check the casing design, you need to design the BHA, you need to run different calculation, torque and drag, hydraulic, BHA tendency, you name it. How many software did you need to do all those things? Any guess? Or anybody have experience involved on that? You run one software, two software? Anybody?
They say 3: petrol, landmark, and
3.
Python.
You only 3? Petrol, landmark, and Python? Okay. Pipe sim? What else? What else? What all the software did you know? Even landmark, there's multiple model. Landmark is a company, right? There is a well plan, there is a compass, there is a stress cat, well cat. Oh, what was it? Well cat, yeah. Stress check, right? You have petrol, you have tech log, completion cementing, they run it themselves, right? So let's say all those applications, if you have all those applications, let's say trajectory, someone design trajectory, right? When you design trajectory, how many times this trajectory information need to be inputted on those various different software? Because all those calculations require trajectory, right? That's kind of the basic. If you want to check your casing design, of course, casing design will ask, what is the trajectory I need? I need to check. If you want to run anti-collision, again, this is together with the trajectory. If you want to check in your petrol, where is the formation top? It's asking about trajectory again, right? So sometimes one information it's been shared to multiple times, and if you're using different software, you need to keep inputting every time you run all this software, right? Do you think how many times you start iterating the plan? Is it like one go? Okay, one go and then everything done until you drilling program, right? So a lot of people thinking that well planning process as a smooth as this, right? We decide, okay, we're gonna drill a well. Okay, where is the surface location? Here, this is the coordinates. And then they ask the geologist, where is the target, right? The target is in these coordinates. Okay, someone need to send trajectory, yeah. So they design trajectory, and then they start asking to the geomodeler, okay, tell me in this trajectory path, what is the pressure window? What is the pore pressure? What is the fracture pressure, right? Okay, they run it in petrol. I said, okay, this is pore pressure or fracture pressure. And then I say, okay, where are we gonna start cutting all those formation tops? Because sometimes when you design the casing, you look at this pressure window, also you want to set a specific formation, right? Okay, this is my formation tops. Okay, what is your expected formation temperature? Okay, they're giving information, and then you design the wellbore geometry. Where are you gonna set the casing, right? Okay, I need 3 section with 3 casing string to be run. Okay, good. Okay, now we need to start looking at that section. We need to start planning the section, and then how many drilling runs you need. Oh, this 12 quarter section is gonna be, I don't know, 10,000 feet. I don't think I'm gonna be able to drill it in one run. But then you start planning 2 drilling runs. Okay, we plan 2 drilling runs. Then you start planning the BHA. You start making decision. Okay, what bit to use, what the drilling tools to use, MW, DLW, you name it, drill string. And then you say, okay, after you read, and then you create the drilling program. Is it the case that always smooth from this one point? No, it's actually not. Sometimes you reach this point, this you end up when you're planning the well and then say it, oh, okay, let me plan the BHA. And then you realize, hold on, the BHA that I can use will not be able to deliver this trajectory. So please, you need to change the trajectory, reduce the dog leg, or changing the inclination, because it's gonna start giving me problem. Then you go back again to here. You someone changing the trajectory. When you're changing trajectory, what happened? Your pore pressure can change, right? Because you're changing the inclination, you're changing the azimuth. It affect those wellbore stability. Where you cut the formation top is changed, right? And then in that case, your casing depth is changing as well. And then you keep going back and forward and bringing back in this loop, right? So it can be multiple iteration. And that's why you end up with how many emails back and forward saying, no, you cannot do that. And then you discuss, okay, let's sit down together in many meetings. So there's a lot of challenges normally that been mentioned by the work construction team. Is just we spend a lot of time in meetings, right? And do you have enough time to actually rerun all different engineering analysis to make sure everything will be okay? You run talk and drag. Sometimes drilling engineers just don't have enough time to run talk and drag or hydraulic because they've been busy on managing this communication, emails, meetings, and everything. Not even start thinking what if scenario. Because if you want to optimize the plan, you need to start thinking, what about if I change from 3 sections to become 4 sections? It's gonna be, it could be better performance. What about if I compare, if I drilling it with motor, compare with the RSS? How is it affect my time versus depth? How is it affect my cost? And what all of it? Do they have enough time to do this? Right? And at the end, do you know how many still doing drilling program? It's just like writing a book, right? It's a Word document. You're typing in yourself. Let's say you finish. You're saying that, okay, my plan, the TD is 10,000 feet. Remember this total depth information, the depth information, sometimes mentioned in many places. 10,000 feet here. Make sure my wellbore schematic is showing 10,000 feet. Make sure my drilling run section saying that I'm gonna drill this last section is 10,000 feet. The casing depth of this one. What happened if you suddenly you go back again this one? You changing again drilling program, saying, oh, okay, I need gonna change that text 10,000 feet. I need to review again the drilling program. Make sure everywhere saying 10,000 feet, changing to the new depth. For example, let's say it's become 10,500, and then I change again 10,000. So a lot of drilling engine complain is they start busy, become like a secretary, right? Make sure all the information in drilling program, it's saying the same thing, right? Sometimes because you just don't have time to check everything, your program said that you're going to drill to 10,000 feet. When you define your casing running program or your casing analysis, apparently still being run with different depth, right? And many things. So maintaining a good coherent, we call it coherent, means all the information is always the same information, right? Or the correct information, or whatever the latest updated information is there, is very difficult, right? Is it clear? Are you agree that that's what the reality of the work of well construction they have doing right now, right? So in reality, it's not just a simple this one line or streamline or little reason. This is what is a drilling program. There are many objects that you need to design, right, in order to compile it as a drilling program. And this is how things connected to each other. And then everything pull to the drilling program. So if you change one thing, there is many other things will change as well. And of course, at the end, it will change your drilling program. So how managing this multiple object with multiple connection, it can be a nightmare. And that is been what consuming our construction team or drilling engineering time at this until now, right? So when this is what is explained, it's a lot of communication back and forward, especially with different role here and back, is like in a it's total chaos, right? And what we expect when we try to transform the way of we working with the digital is to make it organized, and how digital technology help us to orchestrate this process, how we communicate, how we share data, and how things is automatically handled by the software, so we can just focus on more important tasks to do, is making decision, rather than spending time on reviewing the document and checking if the number is still the same in all the pages, and if all the calculation need to be rerun again, etc. Right? So let's look at on why, how we develop all this thing in, especially what I can tell is with the platform that we build is a drill plan. I saw someone raise a hand. Go ahead.
Yeah, you mentioned that there's a lot of miscommunication happening in the workflow.
Mhm.
Is there a certain software or platform you use to facilitate like communication? For example, in programming, we have programs such as Stack and GitHub. Do you have an equivalent to these programs in the oil and gas industry?
Could you explain what is this? I heard GitHub before. Could you just explain to everybody what is this program do?
It's specifically designed for to maintain coherent workflow between teams, which is the main problem I see when you're talking about it. But I'm curious as to whether there is or not a platform like it for oil and gas engineers.
There is. This is the one I'm just gonna talk to you. So I'll explain how drill plan embrace. We actually learn from some of the things that being implemented in other industry, like GitHub as well, right? It's like, if I understand correctly, in GitHub you have like a revision history, you have a traceability, right? You can also branch. Is it correct? My understanding of the word.
Correct,
right?
which facilitates a coherent
So
work.
people can see, right, how different people working together, let's say the program, and then see, oh, okay, this changing and this is what happened, right? So let me now it's it's a good question. Thank you so much for that. Now it's opening me it's allowing me to open this, how we doing well planning now in this new platform, for example, called Drill Plan, right, that we developed. So the goal is to deliver this coherent drilling program for every well. What do we need to do plan well? First, now we need a collaboration space that allow multiple people can access the same project or the same program or same plan together, rather than everybody working on in their machine, their application, and then start sharing data through email. Why don't just bring everybody together in a place? This is the concept with let's say with Microsoft 365, right? Where you can share a document and working it together. Same concept implement. That's why this platform is a cloud-based platform, because the cloud technology allow us people working together anywhere at any time, and then let the system track of any changes. It record revision, record the history, record what things being changed, etc. So we need a collaboration space. Of course, inside that collaboration space, we still need many engineering application. We need trajectory design tool, we need wellbore geometry, we need casing design calculation, we need fluid design tool, cementing design tool, all kind of tools that you need to do the job, to planning those different design objects, right? But on top of that, the tools need to behave or have capability on this is 5 aspects. First is orchestrated planning. How among the well constructed team can work together and then see individual progress, can easily see the activity log of how things being changed and by who and when, etc., etc. Sometimes a company have their own process, right? A workflow to follow. Then the detail plan can implement that workflow, and that's become a guidance for the team to follow, right? Who's doing what, who need to implement. So for example, someone need to provide me trajectory design, 60 days before the start date. Then it will notify the person, through email, say that you have a task to do, please complete by this time, right? And then after that, the trajectory design finish, it tell the system will help you to manage the team, say that who need to be notified, right? Because then after that being done, what things need to be doing next, right? So that's what they call organizational planning. How the system can help is asking you, okay, please do this, please do that, and then as soon as finished, it notify other people that this process already complete, and everybody can see the progress in this platform. How you start automating some of the design, for example, trajectory design, right? Currently, people doing trajectory design. I don't know how many of you try to design trajectory. You're doing it manually, right? You design, okay, this is, you pick surface coordinates, surface location. You say that I'm going to drill vertical until kickoff point, let's say 2,000 feet. And from that, I'm going to start drill 2 degree and then do whatever is landing the well, drill horizontal. And we start thinking, can we automate this process, right? If, for example, like a Google Map, you can tell where you start, you can tell where you want to go. The same thing as we tell that this is my surface coordinate, this is the target I need to achieve. Could you tell me the path, all the possible path, all the possible trajectory? So instead of I designing it manually, let the system doing it and then probably propose, 50, 60, hundreds. Drill plan can provide even one of my, well, I get recommendation up to 1,600 possible trajectory. Because this is not like Google Map, you have exact road. It's just the earth. If you give a constraint, enough constraint, you can tell all the different possible combination mathematically. And what you need to do is just try to choose. How you choose? Depending. You can choose based on, I want the deepest kickoff point, or I want the shortest total depth, right? Or I want the smallest dogleg severity, right? So the concept is changed. You automate, let the application provide you all the possible combination, and then at the end you just need to choose, right? The other thing is many drilling engines just don't have enough. Currently, the process is you design trajectory, you design Weber geometry, you design the fluid and everything. After that, you put it in the engineering analysis application. You select trajectory, you select the BHA, you select the fluid, you select the Weber geometry, and then classic run, torque, and drag. And run, torque, and drag, doing a calculation, giving you the result. This is the expected hook load, this is the torque. Sometimes you just don't have a time to reach that point, not even run the drilling analysis or run, torque, and drag, and then see the result and then tell, oh, something I need to change. We start thinking, those engineering analysis is to validate your design. While you design the trajectory, while you design the BHA, it tells you that your design will work or not work, right? Can we run this automatically? As soon as I submit my BHA, it submit to all different engineering calculation and tell me, is it gonna break? Something will be break, something will break. Is my torque will exceed my top drive capacity, right? So if it always run all the time, whenever you changing the design, that's what we want to achieve, right? And that's what would implement into the plan. In the same time, normally after you're doing all the design, this is gonna be drill 3 section and everything. The next thing the drilling engineer do is plan the activity, right? Because at the end you need to deliver the time versus depth and the AFE. How much is the cost? The problem is, this is the problem, right? You already plan, okay, I'm gonna drill this section in 3 days, 5 days, and later on, before actually start, they said, no, hold on. The formation top is changing. I need to design changing the trajectory. What happened with the activity plan? Of course, now your section length is changing. You need to update again. If that thing can be done automatically, then you don't need to redo everything. You just click a button, update, and then everything is calculated. You always want to learn from your offset, how this information from offset can help you doing that. And at the end is, can I just have a system that help me instead of I'm doing it manually as a secretary, a system that automatically pull all those information and populate as a drilling program, right? So this is what we doing with in drill plan is a cloud-based system where a lot of people can work together, and this is all different tasks need to be done by the team, and the team can monitor, what is still pending, what need to be done. So they manage based on the company standard workflow, or they manage among themselves, and this is where they start communicating each other, and they start in the activity log that they can start seeing who's changing what, and every change is being stored as a revision, right? So you can go back and say, oh, hold on, this plan won't work. Let's go back to the previous version of the plan, right? And let's optimize again. Integrated learning is if we're feeding all this offset data, and for example, while you're doing risk assessment, you just want to see the summary of what happening in offset well. So when I build my risk assessment, I can know, okay, in this section there is a stuck pipe happening. The frequency is 50%. The severity is high. So that's what you need to build. But you need the tool rather than you doing manually. It provides the information for you. The same thing also when you make decision or this time versus depth. How fast is this section being drilled from the offset? And that's how you learn from the offset well. Right? I'm talking about automated design. Anything that can be automated. For example, the trajectory design, right? Then help you design it. For example, even creating this schematic, right? A digital system. Drilling engineers spend hours to trying to just represent their wellbore geometry. I don't know you guys, if you got the task to design this, probably some are still using Excel, some using Paint. You take hours doing that. Now with digital technology, so long as the digital understand what size of the section, you just click a button, it create you a graphical representation of the well in matter of second. And not only, and it can give you a sequence on how the well being construct, right? When you start conductor and everything, this is one schematic. And on top of that, the reason you need this schematic because it's easier for understand, especially for execution team, to visualize what's actually going on downhole, right? And this is important for well integrity management. So they understand, oh, okay, my well barrier, there is a primary barrier, a secondary barrier. You need to make sure it check at all the time at any operation. There's always two barriers, right? And a smart drilling program, how is it work? Because all this information being fed in digitally inside the platform, and you just need to define the template on what chapters in your drilling program and what chart, what table, what information, even a text, how much is total depth. You just need to define the template. So what it did is, if you design change, you just click a button, give me the latest information of the design. It will automatically replace it for you or update this drilling program for you, instead of you have to manually, changing it in Word document, right? Or any other tools you have. So that's just I understand this is very quick brief, but that's some of the things we can do now in drill plan, right? Because that's that takes some of the tasks that take a lot of time of our drilling engineers to design a well. Some other solution that being implemented. Remember, there is three things on how we nurture innovation in terms of artificial intelligence. Something that being developed with the technology company, like for example SLB being developed things in this drill plan. There's something, the solution that being built as it is, like external engine or machine learning engine or model outside that later on application like drill plan can communicate with the system. Now I'm gonna start showing you some of the example that is being developed and start communicating with human. First, how we use artificial intelligence to help the planning engineer to decide the schedule of the rig, right? If we have a lot of rig, sometimes in a campaign, and then you have a plan for a year. We know that during drilling, even you plan 30 days, sometimes it can be faster, it can be slower because of the issue. How those planning engine make decision, you know, when that rig will go next, right? And that's what the job of this planning engineer or scheduler need to optimize to make sure there is less downtime or less unproductive time. This can be, you know, a guessing game for the engineer. We know there is some machine learning technique. Even this is developed by Microsoft, right? This is we call it AI scheduler. Can process this iteration better. It run multiple iteration, and at the end, after run multiple scenarios, it come up with the optimum one and propose it to you, right? This is being used in manufacturing industry, because manufacturing is the same thing, right? They have a different assembly line. Sometimes, let's say they have this welding machine, and they need to make decision where is the welding machine need to go next, and etc. etc. The scheduler is the one doing that, right? How to minimize the movement and everything, and come up with the most optimum plan. So the same technique being used in how to help the drilling team to planning the rig schedule, right? Drilling engineer to decide what is the best BHA combination to drill a well, to drill run. Most of them decide, you know, they make decision based on what worked last time. I'm just gonna keep it until it break, right? But that's not necessarily the optimum. When you're doing that decision, is you assume that the next plan is the same as my previous plan, a previous well, which is probably not the case, right? It can goes to different direction. Probably you even you move, I don't know, 100 meters from your previous location, something can be different there. So how you take a benefit if you've been drilling 100,000 of wells and you've been recording every single data or parameters, you know what bit being used, you know what inclination you go through that specific formation. How the machine learning looking at that information and come up giving you what is the best performing bit, what is the best performing BHA, right? Just purely looking at the data. So it's not like human, it can be biased, right? So machine learning can help us doing this. So because at the end, as a drilling engineer, I just need the answer which one I need to pick to deliver the best performance for my next drilling program. So we build a utility reading all the past drilling runs, and you just select, I need to drill in this field, okay, and then in this section, and we put on more context, and then giving you like a scoring system, right? What is have the top score, you know, until the lowest score, and then you can use that as adversary system to make your decision. Okay, I'm gonna pick this bit with this drive mechanism, right? The same thing also, how do you know that your bit gonna be survive? Because that will affect your time versus their planning. Are you gonna drill it in 1 run, or are you gonna drill it in 2 run? Not necessarily you assume that, oh, last time it worked with 2 run, I'm gonna stick with 2 run. Not necessary, right? So if you've been recording all this data, and then you see how is the performance a specific bit across a formation, across the drilling interval, and then trying to project that to the value plan, then you can have more insight on how my bit will survive, right? So what it's showing in picture here is just how the distribution of uncertainty, of the survival mode, telling you how much is the survival percentage, we'll say, right? Then the next thing is, okay, after you define what bit to use, what the BH use, now what parameters to recommend to use to get the best performance. The same thing, you look at again your previous performance, but you embrace more information rather than just, okay, I just copy paste from what is the recommended in the last drilling program, but now you embrace 100,000 of experience, offset wells experience, and then trying to give you the optimum combination of weight on bit, RPM, and flow rate, and then each of this design is actually is ROP profile, right? The next thing is we do a lot of simulation, right? We run torque and drag, we run hydraulic, we model how is the tendency. For example, how is your BHA tendency is how much dog leg a certain tools will achieve. This is important. You plan a trajectory, let's say with now, even that the higher the dog leg you can plan and achieve, the shorter is the total depth, right? And that is the trend. It's not only you reducing the drilling distance, but you also sometimes you can cover the reservoir longer, right? So now the trend in directional drilling is you keep developing the tools with more higher and higher dog leg. Now even achieve the range of 15-degree dog leg, 20-degree dog leg in the conventional BHA. We're not talking about Suryadi, but yeah, in conventional BHA, before we talk to people talking about 3-degree, 5-degree, now it's even go beyond 10, right? But there is a risk on that, right? If you plan the trajectory, remember the trajectory can affect many things. If you plan the trajectory, let's say with 12-degree dog leg, you need to ensure that the BHA that you design can achieve 12-degree dog leg. Because if during execution the BHA cannot achieve 12-degree dog leg, that's it. You end up with a sidetrack, you end up with cement plug, and it's very costly. So predicting what is your BHA capability or simulating during a planning become very important. Yeah. So the problem is, so far we rely on the physical modeling. There is many finite element modeling, everything, but you cannot model every single situation while drilling, right? So one way to reduce or to inform us what is the uncertainty of that result is through machine learning, because machine learning can see all the offset experience if you record all the information, right? This is the BHA used, this is the parameters is used, this is the formation being used, and this is the variation of dog leg that being achieved while you're drilling that formation using that parameter, using that BHA. So instead of giving prediction so this is the solid line is what being predicted by the physical modeling, or let's say finite element modeling. You give extra information, which is this uncertainty that coming from machine learning model. So this is what we call hybrid modeling, where you combine the physical calculation result with the machine learning model, looking at from the past experience or the offset well data, right? And now they're giving you extra information. Okay, I know that I'm planning this well, but I have uncertainty, so I need to plan carefully my trajectory to make sure if I'm gonna be short on achieving the dog leg, I still have a room to catch up my trajectory, or I have a good chance of success as well, right? Rather than you stick with one prediction. And this concept is being used in many other prediction. Pressure, for example, if you're drilling a very narrow mud weight window, you need to know, the combination of your fluid, of your flow rate, how much you rotate, have to be accurate, but you need to make sure you need to know what is the uncertainty. right? Because otherwise you're in the situation that you are fracturing the formation or you start taking kick, right? So in short, all that being implemented is available now. Many there's many companies that using the platform. Of course, what we achieve is go through the automation and how you can collaborate better is improvement in the in the in the planning time, right? So now let's move to the any question in the planning before I start moving to the execution, right? So there's many areas we can still embrace the artificial intelligence machine learning to help us making decision on planning. And you can go through SP library. There's always interesting case that being presented in many SP conference now, because people know that there is many potential in with the machine learning. Okay, I'm gonna move quickly now. Is already 1 hour 15 minutes. I'm just gonna move quickly to the what we're doing with the execution, right? So now before I show you some of the use cases with the digital, with the artificial intelligence in execution, let's look at how we're doing things now, or even many still doing it till today, right? So drilling program, what is the execution team receive? Normally it come as a document, right? It can be, it can be just 1-page document. It can be 10, 20, hundreds, 200s, right? Depending what being put there. How effective is that being given to the execution team? The drillers, the driller have enough time, or the company man have enough time to read, understand what is the plan, right? Sometimes, as much as drilling engineering planning as details, during execution, people really say, I'm just gonna do as last time how we do it, right? Or I know how to drill this well. I don't need to. Yeah. That still happen, and that's why many companies start talking about what they call it procedures adherence. If you already spend a lot of effort times to plan the best way you're gonna execute, how to make sure the execution team is follow the plan, follow the procedures, right? Because when they start not following, they rely on their gut feeling, or they say, I've been drilling this well for 10 years, I know what to do. And sometimes that's the issue where stuff happen, right? How the driller monitoring the operation? You rely on everything to driller, you only controlling all the machinery, the brake, the pump and everything. How they know as early as possible if something going to happen, so they can avoid an incident. Yeah, how the drillers know is there is coming, and then how the drillers make decision when something has happened. How fast he can react or make the decision, or he need to wait, calling town, and then yeah, it take hours before they suddenly, okay, I need to proceed this way. And at the end is, are they delivering a consistent performance, right? The same speed of making connection, the same speed of tripping, is it the same between even the 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 day tour with the night tour, right? So this is, so I bring you to the execution world. So in Sambaje, what we developed is in a platform called DrillOps, which is the execution platform, and we embedded many AI-driven automation. Is the goal is how this will help you to execute your drilling program, right? The drilling procedures, how you want to same while doing you drilling those as well. You optimize the performance. Of course, even you want to make sure that the wellbore integrity is always protected. You don't want you drill as fast as possible and then you're taking cake or you damage the wellbore. And how we can automate on how you're delivering the SUSU's trajectory as smooth and as fast as possible. So there's 4 area. One is called orchestration, on how you managing the drilling operation, on tracking each individual activity. If you visualize what is the potential risk going to happen, and how you communicate with between company man, with town, with the drillers, right? Instead of just piece of paper flying around and then people confuse, okay, which procedures I need to follow. And the town, you need to spend time meeting and say, you know, we're gonna do this and everything. And then during the execution, I mean during the actual operation, either you have some advisory system that advise you on how to drill a stand or how you need to steer on how you trip, or you let it fully the system control the rig machinery and doing the drilling for you. Right? And at the same time, you automate the ROP, make sure the BHA survive, right? And of course, the execution team is always need to do a report, right? Daily drilling report. This is something that many people do not like to do, but they have to do it because otherwise there is no feedback either to town or for your learning for your next well planning. So if there is a way to automate this process, the drillers will love it, right? And there is. So let's start with orchestrate. Imagine yourself as a company man or well engineers on the rig. How you manage those drilling operation, how you orchestrate your rig activities, right? From what you receive as a drilling program, now it become a procedure step by step, right? From moving the rig, you need to, rack back the pipe and everything. How you, kind of easily manage that through a digital tool, right? So you need you need all this aspect. You need to have a tool that can help you do all this aspect, right? It giving you a list of activities that the drillers need to do or the rig team need to do. It's always telling you what is the risk. So every time you go to a certain depth, it start giving information. Remember, during planning, it's being identified there will be a risk of this. Be careful. This is what you need to monitor. It's very clear for the drillers. It's appear in the display. It's like there is someone always guiding you every step of the operation, right? And of course, anything that happen you want to capture because this will be important for your next well planning, right? So just imagine. So this is where you need to collaborate between the company man, the drillers, the drilling engineers. So the drillers, it has this display. It telling you the program step by step, and then in this program, it telling you the procedures or operational notes. And every time it is a depth, if there's a risk, it giving you a warning, right? But remember, this system need to be smart enough to adapt for any changes. For example, what happens if a formation top is changing, right? Because during planning, you predict, let's say you hit X formation by 2,000 feet. What happens if, based on your log, that formation top is not happening in 1,000 feet? So this, even these operational nodes, you need to understand that concept as well, and can be lively update as how the drilling operation progress, right? And these people, either from the rig side and in town, can start looking at the same thing in real time, right? So they start seeing all this node. So just imagine you're the drillers and your company man, you start seeing this. Okay, I'm gonna drill to TD. Hello.
Hello.
Yeah, it seems I got kicked out for a while. Can you still
Okay.
see my screen, or I need to share my screen again?
You need to share your screen again.
Okay, all right. Can you see my screen now? Can you see my screen now?
Yes, very clear.
Yes, we can.
Okay, all right. And this is the last slide I showing, right? Before I got kicked out.
Yes.
Yeah, all right. So I'll continue. So imagine, so now as the drillers go, so everybody can look at the same thing in town on the rig, and they say, okay, this is what we're gonna do, right? And then everybody can lively update, and all this the blue thing can smartly update it, right? So then the company man can focus on monitoring rather than he's busy creating these operational nodes, right? Yeah, then you can record the activity, make sure what is, you can save, if you can add instant activity if something happened, etc., etc., right? So I'm just gonna quickly move here. So this is help also collaboration between rig and town, reduce, you don't need to, you can still have morning meeting every day, but at least because everybody can watch the same thing and understand, then can you, rather than in the morning meeting, the superintendent town say, could you please report me what's happened the last 24 hours, right? They can just go through themselves because both side is collaborating using the same tool, right? And everything is being recorded, everything being compared with what were the plan, etc. So even the planning engineer can learn as how the well is actually being drilled, so he knows what to do if anything need to be improved while planning the next well, right? So again, it's all about how collaborating between rig and the office, right? And trying to reduce administrative time of the well complement or the drilling engineers. And by managing all these things, we want to accelerate the learning. So uh, 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 any knowledge being captured or an experience can be used while planning the next well. So that is in short. So the digital tool can provide that the platform to doing that. Now we start trying to introduce some smart advisory system or automate completely taking over the rig operation, right? So there's two mode. One is still manual mode, means the driller still taking control of the rig machinery, still taking control of the brake, is still control pump, but he has an advice system to telling him what to do, right? On the other hand, is fully automatic control. You just press a button, drill the stand, and the application will take control, fully take control the how we bring up the pump, how start rotating the top, the top drive start rotation of drill string, how you start taking both automatically. All right. So let's start seeing in the advisory mode. On it provide this advice on three different areas. First is on how you steer the well, right? It giving you feedback. So before, it's the job of directional drillers to decide, okay, what I'm gonna do next to achieve my dog leg, and then start doing calculating with calculators and everything. If we train the system as how drilling directional drillers do this thing, because pretty much like trigonometry thing, right? It's not like art, you have a feeling or there is an art of the aspect as well, but of course, as much as knowledge we can induce to the system, then the system now smart enough to start giving you recommendation, saying that, okay, you are 4 degrees behind the plan, so the next 10 you need to, let's say you need to steer or you need to slide 20 feet from this depth to this depth using this tool face and everything. So this system is start telling the drillers on how to steer the BHE. in this one for drilling, it start giving the driller, it giving all those how much the RPM use, how much the torque, how much the weight on bit, etc. But at the same time, it also can give a recommendation. Okay, you can increase your weight on bit by this much for better performance, right? Then the driller will start increase manually the weight on bit, for example, right? Or when you start seeing that the torque is increasing, they said, okay, you need to reduce, your RPM, for example. So this is becomes an advice system. Start flagging. There is a stick slip happening or vibration happening. You need to reduce the weight on bit, increase the RPM, etc., etc. While tripping as well, with tripping, with the issue with tripping speed, you don't know how much is the pressure reacting downhole. If you pulling too fast or pulling out too fast or tripping in too fast, right? You don't want. But if the system, it can simulate all those things, it can tell you what is the recommended tripping speed. So the drillers know, okay, if I'm pulling this speed, my calculated, swap and surge is this pressure. So I can speed, I can speed up the tripping, or I need to slow down the tripping. So the system advised that one. So that the foundation of this is you need to make sure the visualization, the display is good enough for driller to understand, right? It giving some smart notification as well. For example, during there's a vibration, it will tell there's a vibration happening. You need to, changing your parameters. And it can be used also if you already have a plan, that during planning, for example, the stripping speed can be simulated during planning as well. And if you want to make sure the drilling team follow the plan, it can track what is the plan value or plan program, and what is the driller use and how compliance with the plan, right? Yeah, same thing with the drilling parameters roadmap. This is what for example, this is the how the ROP achieved. This is what the environment use. The orange line is what is being planned before. How I can optimize the ROP. This is the recommendation of weight on bit RPM, and that's what the expected ROP to achieve. And if there's a vibration, it telling you what to do. Step 1, reduce the weight on bit. Step 2, increase the RPM from this value to this value. So giving all those advice based on the learning that the system have, right? The same thing with tripping advisory. I think I explained you in nutshell before, right? Is it connected with the swap and surge calculation, so it knows if there's a room to increase the speed, or you need to slow down because you go to the risk of swabbing the hole, or you surge. Breaking the fracture, sealing the fracture pressure. Right. So that is a file system. Just imagine the driller looking at this display and giving them all the device, so they can have always the like a trusted advisor next to him. The next step is, what about if we want to automate this thing, right? So what the driller's job is just to monitor. We still need human there, not completely, because if something happens, something not work, human need to be ready taking control, right? We're not in the so there's a journey in terms of degree of autonomy. So previously we are level 0, which is purely human operate, and then level 1 is user defined. It's like if you're driving a car, right, and you have this auto steer, right? You still set up, okay, I want to keep the speed 80 meters per hour. You put the number and that's it. Then the machine understand, okay, I need to keep the speed at 80 meters, 80 kilometers per hour. Then it will keep the car like in the cruise control. That is what you call assisted operation. And you start going more and more in advance on how doing more automating the system. You start doing, for example, picking up the pipe, right? A pipe racking system. You just press a button, pick up the rack, and then the robot will pick up the rack and then moving into this one, put it there, grab the tong and everything. So that's when you start going downhole, you start influence many different factors, right? And then that start, you know, going to different levels of artificial intelligence until you completely fully autonomy. This is the same journey exactly as people talking about self-driving car, right? Either you are in the control environment where you just go drilling straight and then the car know, and then what is the next level when we introduce more influence of the environment, someone crossing, there's a cat running and everything, is how smart and how quick the system respond is depending on this different level of autonomy, right? So how far we be able to automate this drilling operation? As I mentioned, now we can have the system in a press a button, please drill a stand or drill to a certain depth, right? It knows how to bring up the pump. It knows how to read to control the brake and start tagging the bottom, come off a bottom, circulates and everything. It execute a list of activity or tasks that the machinery need to do. And in case suddenly there is a, for example, while you're drilling and suddenly you see the trip tank reading a kick happening, the system knows what to do, right? Stop drilling and everything, and then react. And probably this is the time when the driller said that I need to take control, or the system knows what to do, right? The same thing also when you activate auto ROP, let the system, okay, you decide yourself what is the best parameters to get the maximum performance, right? And so the machine will take control of this RPM and weight orbit and try to adjust it until it reaches to the optimum ROP at that particular formation or the particular condition. We start sending different command to the drilling tool, right? To the rotary steerable, to MWD, LWD. Previously, the driller manually controlled the pump or the RPM, sending a sequence high, low, high, low. It's like sending a code downhole through the pressure pulse. Now you just press a button, send this command, send that command, then the machinery can do job better, right? The same thing also auto survey. MWD send a survey. How, instead of someone MWD engineer looking at the parameters to decide, okay, this is good survey, this is bad survey, please retake the survey. We tell the system on how human making those decisions, and then let the system taking over the decision to decide, yes, it's a good survey or it's bad survey, right? The same thing with the auto integrity is if there's vibration happening, how you mitigate that vibration. Auto steering, how the system know how to steer by itself, what the steering tool setting needed to change, and that can be done automatically downhole by the steering tool or in the surface by sending a command connected to this auto downlink. So this is already available now, right? It's being used in different operation around the world at different level, right? And of course, what we're trying to achieve with this is gain more performance, right? So this is some of the how previously everything manual. Now when the system automatically control that, there is improvement in ROP, there is time reduction on sending the downlink, how much time you spend on connection, pre-connection, post-connection. And what actually being aimed is not just getting as fast as possible, but actually what more important is delivering consistency. Because this is system talking about the machine. When it is taking over the human control, because human controls, depending, there's the influence of I'm tired, I'm in day shift and in night shift and everything. That's where start introducing inconsistency on the performance, right? Yeah. So that's how automating drilling process. The next thing is I mentioned about reporting. How we can automate the reporting. This is what what the driller says. Why they say that after long hours, or I'm so tired, and I still need to spend 1.5 hours to create the report, right? Even someone create the report, when you need to use the information, you spend times to on searching the data and sometimes reformat the data, and this is what end up a lot of problem, that we cannot guarantee the accuracy of the reporting. Right? The issue is, if you don't record accurately, this data is required for your observational analysis, for your machine learning study, machine learning workflow, and everything is garbage in, garbage out. If all the information is not accurate, then what machine learn is also not accurate, right? So how we can automate this is, again, using some of those digital technology, natural language processing, or by reading the sensor. Different sensor record different thing. It knows what is, we call it the rig state. What is the what is the operation being done at a particular time? Is it drilling? Because it knows there is a rotation, there is a flow coming, flows run, there is a weight on bit, like the bottom. It knows it's drilling on bottom, right? So it can automatically populate this instead of human saying that I'm drilling from this depth to this depth. Then the machine record itself. At this time, I'm start taking the bottom. I'm drilling from this depth because you have a depth sensor, and then it knows what time it pick up of bottom. It knows what the parameters being used at that time, and then it start writing line by line operation, right? Instead of drillers inputting it manually. Sometimes if driller input it, say that okay, from 1 o'clock until 12 o'clock, I just drilling from this depth to this depth. That is not granular enough if you want to start learning what's going on every single stand, right? So by let the machine populating it automatically, then we have more high granularity of reporting, right? So and yeah, so how the system automatically define the rig state and what parameters being used, it automatically populate those line. If you've seen the daily drilling report, probably you understand what I'm talking about. It's just you completely have a breakdown of operation, because that's important for you to for machine learning system. And later on, this information being used for you to monitor how is your drilling performance, right? How different service company, there is a fluid provider, there is directional drilling provider, they generate their own report, but how easily I can get all those report, reading it digitally, and then start using it to populate my own report, right? That's what we call, we need to start building connectors, or call file bridge, to be able to, even is being produced by different company, but as long as we can define the mapping and everything, we can utilize it digitally and help me, rather than I receive okay from the fluid provider and then typing it again manually to my report, right? Then it just wastes the time. Yeah, instead of just one line of this one saying I'm drilling from this, now you can break it down to every single stand on what's going on, right? And this is what FileBridge is talking about. Different company say this one. If I have to move some of the information from this report manually, then it consumes all of my time. What about if just feeding this document and the system smart enough reading the information that required to populate my report, right? So just kind of go quick is, again, I mentioned about it's all depending on using the information from the rig sensor to detect what is rig activity going on, and then reading from this natural language processing, reading from some of this report, taking the information and then populate my to my report, right? So that is in reporting. The other aspect that we can do with artificial intelligence is how we help to monitor our rig equipment. One of the key on drilling operation is we need to know when we need to start servicing some of the equipment, and we don't want a breakdown happening while we're drilling, because that can, suddenly you're drilling in problematic formation and suddenly your pump is breaking down. You're gonna stay stationary there, and then by the time you finish fixing the pump, you got stuck. Right? You don't want that happen. So if I can monitor my rig equipment, and having a early detection if something going to happen, and this technique is being done in many other factory, right? Detecting how is the different parameter, the pressure, the temperature, the vibration, and giving information for the rig contractor, say that it's better you the next time you have a time, because it's gonna break down, predicted, let's say in the next couple of hours. Then they can plan it better before it's actually something happen during the operation, right? And that's what machine learning can do. Yeah. Just gonna go quick, and this the same is basically how you detect that something's going to happen to your rig equipment. Same thing with the video surveillance. Video is a data, right? And how you use those data and use it, process it, and through machine learning to know if something is not right or something need to trigger alarm or notification. One way this being implemented is to HSC, to monitors, right? It is smartly enough to know area is safe or not safe, right? And that's through video surveillance and data processing. And of course, there's machine learning model needed to build first to let the system understand which one is good, which one is not, which one is bad, right? Okay, the last thing I want to talk about, that's planning execution. Now is how we learn. This is called drilling insight. We've been collecting a lot of data during operation. How we learn. First is how we learn and provide a real-time decision. You monitor all those parameters or the log from the sensor downhole on the surface. You can have monitoring center in town or even rig itself, how to use that information to predict if something going to happen or how to improve performance. And after that is how you learn, evaluating multiple wells and then feedback again to the closed loop for your next planning, right? So there's two areas: real-time decision support and how you learn from your past performance, right? So first is how you collecting the data. That's important, because if you don't collect it and you want this system smart enough doing that, especially remember it's reliant on the data. So sometimes you need to have a system can QC the data itself, if the data, the information being feeding is good or bad, or you need to exclude it, right? Then through some smart analysis, it using that to interpret the data and trigger some alert or notification. And sometimes you compare those data with some engineering analysis as well. So you know that you are still following the trend or you are way out from the trend, right? And later on, then you start trying to gain insight from your performance, especially. So this is what the real-time operation center engineer do right now. Is many people, managing the data, changing the logs and everything, and then sometimes they look at the logs and then sometimes they still miss out something going to happen, right? But if we replace that with the application that's smart enough to interpret the data, then they can help you on identify some of these issues. For example, the stack pipe risk, if there's a vibration issue, if you have a influx or well control issue, how you improve your drilling performance, what parameters you use, and etc. Right. So a lot of machine learning model being developed in this area, and the goal is instead of each person monitoring every single line, let the machine reading those lines and then interpret, and they just trigger you alert if something need to be taking action or may put you more attention, right? And then you can send notification over to whatever people, to drilling manager or whatever required to see, right? Rather than someone watching it all the time is waiting until some alerts is being sent, right? For example, this is stack pipe incident. Is using Bayesian network, one method of machine learning, and it tell if your well is going to higher risk situation, right? And when you start dealing more multi-well, you start moving to multi-well analysis, but you can do analysis on single well performance and then see how it's going, how much time you hello.
Hello.
Yes, I got kicked off again, right? All right, I'm sharing again my screen.
Okay.
Let me know if you can see the screen again.
Yes, I can see.
All right. So I'm just gonna speed up because we about to run out of time, right? So basically the insight is basically performance insight is start looking at using the machine learning to crunching onto the data of your multiple wells performance and start giving you insight in terms of what is the best performance, worst performance, what is the recipe that being used for delivering those best performance, right? And start suggesting you, instead of you manually pick what is a similar well to you, machine learning knows, telling you if this is what the well that you're going to plan, this is the recommended offset well that you need to use as your reference. And then it is giving you breakdown on how this well, what is the best performance of those offset well is being recommended. This is the recipe, right? It's like, okay, this is a suggestion on how you should drill the well before you actually start planning the well, right? Including on what is the event that happened. So it's highlighting you some of the risks that potentially can happen in your well, so you can plan the well better, right? The other thing is, if I know the performance of that, now, for example, operators, you need to decide what is the best drilling rig to be used for this job, and who is the best supplier, right? And this can be used by the procurement engineer to make those decisions as well, because they're giving you information of how is the performance being what happened in the past, right? And then the same thing also on recommending, back again to what is the recipe for the success on smartly recommended by machine learning. After looking at all this data, what is the best parameters to use? And again, closing the loop. Quickly, those things happen. Sometimes it takes time also when you're going back to the town and then planning next well. Now the trend is start saying, if I already build a machine learning model, how I can move that machine learning model to the edge. The edge means back again to the rig, so the decision can make faster, and then that what feeding to the smart automation that happening in the rig, right? Is instead of going back again to town and then the driller get inside, now the driller have this trusted advisor next to it all the time, which is it's like, again, this is the dream of the AI, right? It's a smart system, I don't know what do you call it, and then they say, advise me for this, advise me for that, what to do with this. And then, but in the same time, we can still communicate with the support system in town. That's what the dream of moving the intelligent engines back again closer to the where execution happen, because that will make the time decision faster, right? And yeah, just not gonna talk about the concept, but yeah, the idea is whatever that can be built it as machine learning model, put it back again to the rig side. And at the end, this is what we want to achieve. We just make every well better than the last, right? Through digitizing, embracing digital technology through this infinity loop of planning, execute, record, and then learn or evaluate. So that's all I have. Hopefully, I know it is quite a lot of information. It's hopefully, but giving you idea what's going on in digital drilling, what technology available, what the development being done, and then we still continue this journey, this digital transformation, on trying to innovate and create more solution, right? And the dream of automating this whole operation is still going on until now, right? All right, so that's all I have. So I'm open for any question you have or any comment. We still have 5 minutes of our planned time, but I'm happy to stay longer if you want to discuss more, right? Yes, Abdul.
Yes, you talked a lot about drill ops and drill plan. Is there
Mhm.
more information about these platforms available online, or is it exclusive to
Yes.
SLB employees?
No. If you go to slb.com, just type in drill plan, drill ops, you will see a lot of information there. Right? This is commercial product already, so all these details you can see it there. You can, there's many SP papers on this territory, this area as well. And yeah, if feel free to contact me also if you have more question that you want to ask. I'm happy to share as well.
Right, thank you.
Yeah. Any other question or comments? Anything you want to discuss?
So now there's no question. So,
Okay.
okay, dear attendees, please join me in extending a heartfelt thank you to Mr. Hendrik for this insightful
Anytime.
and inspiring session with us BOGSB student chapter. Thank you, Mr. Hendrik. We hope to see you in more of our future courses.
Thank
And
you so
also,
much
I'd
for
like,
moderating this.
you're welcome. And also, I'd like to thank all of you for gracing this session with your presence.
So my last comment is, remember, this is all about innovation, right? And then the good start for innovation is where you are now, right? Because you still have open mind, you're still learning many things. But again, we understand this digital transformation is not only work by technology provider ourselves, but we are make sure it's open for any idea, anything that can be done even in the local level. A lot of we grab a lot of startups company, right? Because there's so much the technology company can do, there's so much the operators can do, but we saw how is the success of a lot of digital company, right? It's all about startups, right? And then that's why we want to make sure we get the benefit of innovation as well through some of these young spirits or people who have a fresh mind, fresh idea. Yeah, so hopefully some of you will start the journey to innovate.
They're asking if you can share with them your LinkedIn account.
My name is Hendrik Suryadi. You will find it. I don't just find Hendrik Suryadi, right? Or that's how your things. Whoever is your student chapter president also found me, right?
Okay, great. Thank you.
All right. So thank you so much for staying with me and listening to me for the last 2 hours. It's my pleasure to share all this.
It's our pleasure to have you on here.
All right. So bye.
Goodbye.